Okay. So let me start discussing this thing. Today I am going to discuss about number one. I'm going to discuss Rees regression, Number two, Lasso regression. And number three, elastic net. Elastic net regression. So it was discovered, if I remember correctly, something like late 60s or 70s. Understand? Maybe late 60s, if I remember correctly, or early 70s, something like this, between 60s. And then I want to tell you, this was 1996. And this one is 2006 or 7, something like that. Okay. Try to understand the fundamental thing. This is the regression model, right? This is the regression model which we know all. All of us know about this regression model, right? So multiple regression model. In this multiple regression model, it has been written beta 0, beta 1, x1, beta 2, x2, beta 3, x3, and then it will go beta k, xk plus epsilon. Okay. So what is the main problem of this regression? There are a couple of problems. If your explanatory variable, independent variable, predictor variable are correlated, that means if there is a multicollinearity. What do you mean by multicollinearity? This variable has some type of correlations. Understand? In such a cases, the estimates of these become inflated, become very big. If become very big, predictions will be very big, right? Are you understanding? If explanatory variable has some kind of linear relationship known as the multicollinearity, in such a cases with those multicollinearity, if you estimate the model and if you make the predictions, that predictions will be erroneous over predictions. That is the main problem. Understand? Yes.
So the magnitude bigger or just
it is the magnitude will be bigger. So beta 1, beta 2, beta 3, all of these things will become inflated, it is said. Okay, it's become inflated. For example, if there is a negative correlations, that means, so beta 3 is suppose negative, right? Without correlation, but with correlation, it will be bigger negative number. Understand? Bigger negative. This is the problem of the multicollinearity problem. Okay. In such a cases, there is a regressions that has been used to handle this type of situations. Okay. Everyone in here know the Lagrange multiplier, right? Lagrange multiplier. See, some people come up with some ideas, then they become famous. What is Lagrange multiplier? Very simple thing. What? Simple thing is what? Suppose I have this is my function x, y, z. Lagrange multiplier is what? I'm explaining you, okay? Lagrange multiplier is what I'm explaining you. Suppose I want to minimize or maximize this. I want to like minimize this. Okay? Under the condition that sum of xi square, y, sum of x square, y square, and z square equal to, suppose, a constant k. I want to minimize these things in such a way that if I take the square of x, square of y, square of z, will be a constant k. So that means I want to minimize this one with that condition. You understand what does this mean? So more specifically, if I want to write, Lagrange multiplier is what I am writing in here. X, y, z is the function, any type of function. It could be like e to the power x cube 5 x square and 9 log sine z square. So suppose this is the function. Here, this is the function, right? And then x takes value. This is the condition. X takes value 9 to 1. Y takes value 5 to 4. And z takes value 1 to 0.5. This is the condition. I said that, well, I will maximize this under the condition that x square plus y square plus z square should be 25. Take x, y, z value in such a way that this sum equal to 25, so that this minimization, I will minimize x, y, z in such a way that the values of the x, y, z that will come, if you square, it will be 25. You understand? Are you understanding? So I want to write here, maximize this in such a way that this equal to 25. This is the condition. Clear, right? So I put the restrictions, okay? I have given you these things, but remember, x, y, z value should be that value, so that if I square them up, it must be equal to 25. It must not be 24. It must not be 26. You understand? I give you restrictions. So when we went to the high school, dad give us some money, right? This is the amount of money you will go and come back. And the remaining money you will eat for your lunch. This is the condition, right? Every day he put the condition. I said that you can maximize these things, but the condition is that x value could be 5. If x value could be 5, y should be 0, z should be 0, right? Understand? If x is the 4, then it is 19, and then this is equal to x equal to 4, 16, and y equal to 3, 9. 16 plus 9 equal to 25, and then z could be 0, right? Understand? So that is the condition. So what did Lagrange thinks? Well, Lagrange come out like this way. He put like this, fx, y, z, and he put here plus, and someone argued that I want to put here minus. He put here plus, then he put a lambda in there, then he did it, what? X square plus y square minus z square minus equal to 25 equal to 0. So he put here 0, and then that 0 he replace here by this. X square plus y square minus z square minus 25 equal to 0. This is equal to 0, right? This is equal to 0, right? So this is equal to 0, right? I'm plugging 0 there, right? This is the idea. He said that, well, this is your function. This is your function. I keep it like, I add there 0. You understand? He said that I am adding there 0. Now, if you start fighting with him, no, I am adding here 0. I am adding here 0. This is lambda times 0, lambda times 0. Then what he did in here, must differentiate it with respect to x. These things gone, right? Differentiate it with respect to y. This 25 gone, right? Differentiate it with respect to z. This 25 gone, because this is a constant. So this is a 3 function that involve x, y, z only. Are you understanding?
Yeah.
Lagrange multiplier. Okay. We are so lucky that we are born in this. Suppose if you are born in 16th, 17th century, what will happen? Most of the things are not developed, right? There is not a big volume, right? Everything is in there, right? That is why now a person is more knowledgeable, because all the things is available. If I have anything come to my head, immediately check in the Google. Do you know how many kinds of number of genes we have in our body? How many? I don't know this. I was doing research at number. More than 100,000 genes. And then Genome Project was declared in 1993. When the Genome Project was started, government gave a lot of money. Okay, and then they are thinking that if you find the complete genome sequence, any disease can be treated immediately. And then when they started this project, they said, oh my God. Even still nowadays, science and technology in very advanced stage, we do not know how many genes people have in their body. Okay, I just read a three paper piece today. So I just want to discuss these things to you. Okay, why I discuss this Lagrange multiplier? These things is going to be used in Rinse regression as well as in Lasso regression. Clear? And this is what they know, they name it, maximize this. This is called the penalty. You know, in the soccer, if you make a handball, what they will give you? Penalty, right? They add you penalty, right? They call this penalty. They call it as a penalty. They're adding a penalty here. Why penalty? This is called the fine or penalty. What? Penalty is this. I cannot, this is your restrictions, right? 25 restrictions. So they put a penalty. This is the D box. Within the D box, you cannot make foul, you cannot make handball, right? This is the restrictions there. No handball, no foul. I give you a penalty. This should be equal to 25. And then if you differentiate these things, then you will get the result. I hope you understand these things. Why did I write it? I should write it in there. I didn't write it in here. Okay. Anyway, so now, as you have understand what is this, now I want to start discussing about Rinse regressions. Okay, Rinse regression is this one. You are writing like the, this is called the residual sum of a square. Residual sum of a square you will write and you will add a penalty in there. For example, if you want to write here, residual sum of a square. If I want to write here residual sum of a square like this, our purpose is to find the least square estimates of that under the condition. Here I am adding the condition. What is the condition that I am adding there? Lambda sum of beta j square minus k. That means now see why sum of beta j square, right? Why sum of beta j square? He choose beta j square penalty. Are you understanding? He choose beta j square penalty. And then I put here k. So that means this sum of this square must be equal to k. So that means this and this are the same quantity. I am actually adding a 0, right? Exactly same thing like the way I wrote there, right? This is just, what was the condition? Subject to the condition that sum of square of beta j equal to k. This is the subject to the conditions. So I am adding here lambda times 0 actually. Okay. Now, can anyone tell me what is this equal to? Beta 1 square and beta 2 square equal to 1. What is this equation? Circle. Do you remember that? This is the equation of a circle from origin, right? So this is the equation of a circle, x1 square plus x square plus y square equal to 1. This is the equation of a circle where center is at origin, right? You already forgot this thing? Do you remember this is the equation of a circle, right? X1 square plus x2 square equal to 1. Like the way you have an equation of a straight line, y equal to bx plus b0 or c something. This is the, so this penalty is called the circular penalty. This penalty is called the circular penalty if it is two-dimensional. If it is two-dimensional, this penalty is called the circular penalty. Circular penalty means this is the circular penalty. Okay. This is called the circular penalty you are adding there. So now what we want to do, we want to find the regression estimate. You remember the day, I think in the second week when I started, second week or third week? Third week when I started multiple regression. So I estimated these things, right? How to estimate beta 1 and beta 0. So that could be written as like this. This could be written y minus x beta. For some reason, this could be written as y minus x beta plus x beta. And then plus, I can write here lambda, and then I can write here beta transpose beta. Okay. And then I can write here lambda k. Okay. I can write here lambda k. And after doing this, if you write like this way, it will be y transpose y minus beta transpose x transpose y, and then y transpose x beta, then beta transpose x transpose x beta plus lambda beta transpose beta minus lambda k. Minus lambda k. Okay. Now, by rewriting these things, y transpose y minus, these two are the same things. If you take the transpose over there, these and that are the same thing. This and that are the same thing. So you can write here 2 beta transpose x transpose y. For example, take a transpose over there. If you take a transpose over there, this will exactly convert it to that. Okay. Now you can ask me, why do I take transpose is there? Can anyone answer my question? During the computational process, you are biasly putting transpose in there. Why are you specifically in here? You are so biased. You just want to make them similar, so that is why it is coming to your head, you put there. Anyone has any answer? Do you understand my question? The question is, if I put their transpose, this exactly turns into that. Why? And how it should be accepted? Why should we accept this thing? Do you understand my question? Not really. Okay. Yeah. So if you take the transpose, why should I believe? Why shouldn't I believe? The question is, why shouldn't I believe? This will give me a different things if we take a transpose over there. You understand the question? Okay, let me write in that big board. The beta, I don't know if the pen like this way. Beta X transpose Y, and then I have a Y transpose X beta, right? X beta. So if you take a transpose over there, then what will happen? Beta hat right? So then there is a 2. Clear? So the question is, during your operation, why you partially targeted this one? You are so biased. Why you partially target 1%? Like there are 5 quantities, 6 quantities. Why did you target only one? Do you understand my question? Why did you target only one thing? What other thing is wrong with that? You can only do these things if it is scalar. So what is scalar? What is scalar? If you multiply these things, it will come up, will give you only one number like 7. And similarly, if you multiply these things, this will give you a 7. Understand? How? If you don't believe me, let me put there, okay? So beta 1 equal to beta 1, beta 2. Okay? And then here x I equal to put 1, 2, 3, 4. Okay? And y equal to what? I put y1 and y2. This is that, right? Now multiply these things. What are you getting? This and that you will get here. This and that you will get in there. So beta 1, 3 beta 2. And if you multiply this, 2 beta 1, 4 beta 2, right? And then if you multiply it now with y1 and y2, what are you getting? Beta 1, 3 beta 2, y1, y2, plus if you multiply this one, 2 beta 1, y2, 4 beta 2, y2. Clear? If you add them up, then you will get only one number, right? So suppose it is equal to 1, it is equal to 2, it is equal to 1, it is equal to 1, it is equal to 1, it is equal to beta 2 equal to 2, beta 2 equal to 1. Where is the y1? Where is y1? This is the y1, right?
So it's beta 1 plus 4 beta 2 y1.
Okay. y1, beta 1, 3 beta 2. This is y1, right?
Yeah.
y1. Yeah. So now if you, this is suppose this is equal to some number. So you will end up with only one number, right? Because if you add this number, multiply, you will get only one number, right? Similarly, if you do these things, you will get only one number. So that is why I can do the transpose during a operation. Understand? Understand or not?
Yeah.
You understand now?
Yeah.
You look unhappy. Are you okay? No? Okay. So let me convince you so that you would not be embarrassed before you're a student. Okay. So let me go there actually. Let me go there. So the question is like beta transpose X transpose Y will give us same thing as Y transpose X beta gave us, right? Y transpose X beta. Let me define these things. What is beta 1? Suppose beta 1 equal to your 1 and 2. What is X x equal to suppose 1, 2, 3, 4. And then what is y? Y equal to 4 and 5, right? Right? So now, if you multiply these things, what are you going to get? Here you get 1 and 6. So that means you are going to get 7 in there. If you multiply it here, 2 and 8, you are going to get 9 in here. What? Why? 1, 1, 1, 6, 7. And then there is 2, 8 is 10. 10. And then here you will get 4 and 5. So there is 28 plus 50, right? So you are getting what? 78, right? So now plug it in there. Y equal to 4, y equal to 4 and 5. And then x equal to 1, 2, 3, 4, right? So you have to, this is x transpose, then x equal to what? 1, 2, 3, 4, right? Because it is a x. This is the transpose. And then I have a beta. Beta equal to what? Beta equal to now 1, 2, right? Yeah, so I transpose this, right? X transpose 1, 2, 3, 4, right? So now it is 1, 2, 3, 4, right? So now 1 and 2, this is 1 and 2, change, right? So now if you multiply, you will also get 78. You will also get 78. Now, if there is a matrix with 1 row and 1 column, suppose A is a matrix that has the element 1. So transpose of A is also 1, right? Right? If there is a matrix A that has only 1 element, then transpose of that is also. So that is what during the indications part, these things happen. Now, we have to do all the differentiation. If we take the differentiation of this part, and then plus if you take this beta hat, beta transpose, then if you take x transpose x plus lambda I, and then plus beta, if you take this, and then you will have a finally, the last part is the lambda k, plus or minus doesn't matter. This is what you got. Now, if you take a differentiation of that, yeah, this one. So what I did in there, yeah, I just factored it out, okay? Yeah, these two things I have written like that way. Okay. And it should be minus, it should be plus, right? It should be plus. Clear? So now if you take the derivative of this, if you take del residual sum of square divided by del beta, then what will happen to x transpose y plus 2 x transpose x plus lambda I comma beta equal to 0. Other part will be gone. Okay? Other part will be gone. Why is that lambda? Lambda. Why? This is. Yeah. Okay. See, this beta transpose is in here, and this beta is in here, right? And then lambda, lambda, this is going in the front, this is coming in the back, right? So lambda is in there, right? So X transpose X is in there. So this is called the identity matrix. This is actually a matrix format, okay? This is actually matrix format. If matrix format, you have to write it in here, then this is the matrix, okay? This is a matrix. This is the vector. This is the vector. So you have to write it like this way. Okay. So now, question? This one? Yeah, this is -2. Yeah, there should be one negative otherwise. So it should be negative and it should be positive, right? Yeah. Otherwise, the result will be negative. Yeah. So from there, now my purpose is to estimate beta hat, right? If you want to estimate beta hat, what you will have to do? You just need to multiply these things by this approach. So beta hat could be written like this way. Okay, let me write it further. So you can write here 2x transpose y equal to 2x transpose x plus lambda I and then beta. I can change them, right? So these two canceled out, right? These two canceled out, right? So now if you want to do these things in the both side, you want to estimate this one. If you want to estimate these things, now do this x transpose x plus lambda I inverse x transpose y. Then you will get here x transpose x plus lambda I inverse times, you can write here x transpose x plus lambda I beta. So in both sides, I multiply by x transpose x plus lambda I inverse. This is the way you can conduct matrix multiplication. Understand? So now this times that equal to 1. So this is gone and this is the solution. So final solution is what? Beta hat equal to x transpose x plus lambda I minus inverse x transpose y. This is the final solution. Okay. This is the final solution. So when there is no penalty, circular penalty, two-dimensional, that penalty is called the circular. But if you, in the general public, you will say that this is circular penalty, they will not accept these things. Clear, right? Two-dimension. If there is a two variable, x1 and x2, yes. This one, this is called the estimate. When you differentiate these things, when do you conduct the operation of differentiation? To find the minimum or maximum, right? So if you differentiate this and solve, then you will put a head. This is called the beta head. Understand? Up.
That 2 plus 2.
That too? Okay. So if you differentiate beta square, you got 2 beta, right? Right? So now there was a beta had X transpose X beta. How many beta is in there? 2 beta, right? So 1 beta reduce. So it is just like the 2 betas or something like that. Because matrix formation, you have to write like this way. So take a look at the previous one. Yeah. If you take a look at that, here is beta transpose beta, right? 2 beta. So if you want to write like this way, sum of beta I square, how can you write it? Beta transpose beta, right? Linear algebra, right? Right? So how did you write this? You write there beta 1, beta 2, beta k, and then you write here beta 1, beta 2, beta k, right? Then if you multiply it like this, then you will get this one. I should spend some time when I did the multiple linear regressions. But I was assuming that you are the smart people. You already know all of this. Okay. If I write in the board, my handwriting is better, but I want to also record. But from the next semester, university encourages all professors and students come to the class and study during class. And most of the companies now forcing their employees to come. Okay. People are only becoming very, very like machine oriented. And if they do not come to the office, they are more and more isolated. They need to be social person. Okay. Anyway, so you understand the derivation of Riesz regressions and you understand why we need to use Riesz regression, right? Riesz regression is nothing but the same multiple regressions, but I am minimizing, I am finding the estimates of the beta under the conditions on the regression coefficient. Regression coefficient, sum of the squares of the regression coefficient must not exceed a certain threshold value. Understand? That is the main thing. You understand? No, like, so let me take you again in here. That is why I discuss what is Lagrange multiplier. Okay. So this is, take a look at this. This is the multiple linear regression model, not plus sign. Plus sign is not included, right? This is the multiple linear regression model. Our purpose is to minimize the error. Okay, residual sum of square. What we did, residual sum of square plus a zero quantity. This is zero quantity. Why? This sum of this square minus c equal to 0. I added this penalty so that I am putting restrictions. So you cannot go unlimited values for the zi's. This sum of this square must be equal to k. That is why I am forcing them. Clear? That is why I am forcing them. And then I do the operations things. So, and then finally ended up with a solution. Ended up with a solution. I will upload some material, try to understand those things. Like they are writing these things. This is X1 and X2 in this case. So this is the penalty beta 1 and beta 2 that should be in there. And then there is when there is a you are minimizing residual sum of square. So this is the thing you are minimizing that part from there so that it can come in there. So from there, so let me draw in there so that you will understand what I want to do. Hopefully, I can draw a good picture. This is the sum of beta 1 and beta 2 square must be in there. Sum of beta 1 and beta 2. So what they are doing, they are minimizing this. This is the ellipsoid. So when there is a more than 2 variable, x1 square, x2 square plus x3 square equal to 1, that become ellipsoid. Understand? That become ellipsoid. So you are minimizing actually this part in here, and then you are bringing them up to in here within this boundary. What they want to tell, so it can come in here. This is called the residual sum of square to minimize this thing. And minimizing this thing, so when you put this, it will come like this way, but you can touch in here before touching in there. If it will touch in there, here x equal to 0, right? You understand, here x equal to 0, right? And here y equal to 0, right? Okay. So next one, when I am going to do, this is not a point of discontinuity, but next one, which is called the lasso, when I am going to draw that thing, you will see there will be a point of discontinuity. In that case, high chance that it will become 0 in there. Next one, when I am going to write. So what they are doing, this is the beta 1 plus beta 1 square plus beta 2 square plus beta 3 square. This is what our value should be. And this is the minimizing the sum of square. This is the multi-dimensional actually. And they are dragging it in here. They are dragging it in here. I can show you some materials from there already. So Rees regression, derivation. I hope there is a picture. You do not have a picture? Okay, they do not have a picture. Okay, if they do not have a picture, then let me see if there is a picture for Lasso regression. In here, no, I want to see the picture. I want to see the picture. No. Okay, it is also not in there. Mathematical background of Lasso, and let me see this one. Here. So this is what like x1 square, x2 square is going. Take a look at this. Take a look at this. This is what beta 1 and this is what beta 2. And this is what called the ellipsoid, because this is the residual sum of a square. Residual sum of a square, there are multiple variables. So these multiple variables, I'm minimizing this. As I am minimizing this, I'm dragging it in there. But take a look at that. This does not touch in here. Before touching in here, it's touching there. Are you seeing? But on the other hand, are you seeing they put a line in there? So when it touch in there, in this case, beta 1 equal to 0. Are you understanding? Are you understanding? In this case, beta 1 equal to 0, right? But if it touches in there, then this is the point of discontinuity. Beta 2 equal to 0, right? And this is the lasso. Now I am going to discuss these things. Yes. Good question. In the reality, can we get just the 2 dimension? Can we think in our psychology 5 dimension, 6 dimension? No. So in order to make you understanding how 2 dimension things is going on, that is why they have drawn it in 2 dimension. But in the reality, we will deal with the 100 variables, right? This is dimension reduction, right? But if there is a 2 variable, And one variable is totally unimportant, not important at all. How to kick that out completely? It can kick out, but it can reduce. Understand? So suppose there is a 100 variable. They take a gene sample, first gene, second gene, third gene, fourth gene, fifth genes, right? And then first person, second person, third person. See, gene is coming like this way. Gene 1, gene 2, gene 3, up to gene, suppose 100 gene samples they have taken. This is the gene type 1. Don't mess it up. This is the first person, second person, third person, fourth person. So first person, first type of genes, first person, second type of gene, right? So bioinformatics class, if you take, you will see high dimensional data. That means lot of genes, 100 genes, but the sample is just 50%. So 50% giving you 100 different types of genes. This is very expensive. That is very expensive if you do the PhD in bioinformatics, biostudies. In such a case, some of these genes are not at all important, right? So how can I kick out then? So if you use just the multiple regressions, they will give the all estimate. If you use the Ries regressions, they will shrink. They will reduce the estimate. But if you use the Lasso, they will kick out. Yes. So here is my point. Suppose you have a 100 covariate, right? So which one you're going to use? All covariates are not of same importance, right? You want to kick them out, right? You use the Lasso. But on the other hand, if you see that there is a 15 or 17 covariates, so all of these are important, but there is a high correlation, you can use the Ries one. Got the point? So when you use the Lasso gentleman, they are very famous Stanford person. His name is Robert Tipchirani. See, he does just a small thing, but become famous all over the world. This is the penalty, okay? This is the penalty. Beta I xi square. He just did these things. Lambda sum of beta I. He just used this penalty. Understand? Just this. Previously, it is sum of beta I square, right? Listen carefully what I am saying. This is he did in 1996. This is he did in 1996. This is equal to that. This is the equation of a diamond in 2 dimensions. In 2 dimensions, this is the, in 2 dimensions, previously it was the circle. Now this is the dimension. How? Let me explain these things to you. Try to understand the theory, okay? So many people, when I was a graduate student in the 4th year, 5th year, I was sent by the department to some conferences, some training, all of the things. One Harvard professor came, he said that during your lifetime, try to develop something small, but very influential. Then he said that, the Harvard professor said that. See what Robert Tipchirani did? He just had this. This is existing, and Ries regression developed in late 60s, 70s, and it takes 26 years to put this. Why people are afraid of putting these things? Can anyone of you guess? What? No, so let me write it in here more explicitly. So it was regressions developed like 200 years ago, 1805 by Galton, right? It is developed by 1805 by Galton. In the straight line, he just put an arrow. That is become a model. I wrote a multiple equation and I asked you the question, how can I estimate this thing? You remember? 2 equations, 2 unknown. There is a finite number of solutions, right? 2 equations, 3 unknown, infinite solution, right? Two unknown multiple equations. I said the least square. You remember that thing? Remember? So 1805, these things were discussed. Like almost 200 years later, this was proposed, Ries regression. Do you have a pen? Let me see if any of these pen work or not. What? Right. No, do not need to go. I don't want to waste time. Okay. So now, this was the lambda sum of beta square. It is something like 1970s or 65, something like that. This is called the Ries regression. And then it takes 26 years to add this penalty. People are thinking during that time, maybe this is not differentiable. How can I obtain the solution? This is a discontinuous function, right? Absolute xi discontinuous function. Now, let me show you how this is the equation of a diamond. Let me show you how it is the equation of the diamond. There are plenty of interesting material. If you want to learn more, you will really enjoy these things, the materials that I have, I will provide, okay? Take a look at that. Suppose you have this equation, xi sum of xi, I equal to 1 to 2. So then you will get what? You will get here x1 plus x2, right? Right? x1 plus x2. So now you can write these things. If x1 is positive, x2 is positive, you will get this equation. If x1 is positive, x2 is negative, then you will get this one. Sorry, this is negative. You will get this negative. If x1 is negative, x2 is positive, you will get this. If x1 is negative and x2 is negative, you will get this. So sum of this in two-dimensional reduced to these four equations, right? Are you understanding this or not? Why this reduces to that? Do you understand this or not? No? You understand this, right? Because if x1 is positive, then it is just x1. If x1 is negative, less than, it is negative. Both of them. Now this four equation is forming a diamond. How? Take a look at that. How it is forming a diamond. Here, x1 and x2 are positive, right? Then here, x1 and x2 are negative, right? Here, x1 positive, x2 negative, right? Here, x2 is negative and, sorry, x2 is positive and x1 is negative. Are you seeing diamond? Then the idea comes that, well, this will be the point of when that figure will travel. When this figure will travel, this figure will touch in here. We will make some then 0. In this case, beta 2 equal to 0, right? Are you understanding? And you can ask me questions. I understand this one, you are plotting that this is the restrictions. Okay, this is the restrictions. So like the way this is the circular penalty, this is the diamond penalty for the two dimension. For the two dimension, be careful when you speak before the people, okay? In the two dimension, this is a circular penalty. This is a diamond penalty. So now the question is beta 1, beta 2, I understand. But why these things is coming like this way? Remember, this is looks like an ellipsoid, right? Ellipsoid, this is looking. You are minimizing this, like the sum of square that sum of square residual, you are differentiating and you are minimizing this, right? So minimizing this what with respect to betas. So this is the sum of square, the solutions that are in there. This is the all the center is in there. This is circulating here. This is ellipsoid. So that is why like you are dragging it down. So when when this is gone in like this format, you are bringing it in here. So the solution is in there. So some of these things will become 0. Clear? Now I want to derive this, the solution for Lasso. Clear? So solution for the Lasso, we will do case by case. How? It is not differentiable, but if I break it in 3 parts, sum of lambda beta I, sum of lambda sum of negative beta I, lambda sum of 0. When beta I equal to 0, then itself 0. When it is positive, then it is positive. When it is negative, then it will be negative. This sign will be changed. And then I will take the differentiation. Clear? Are you understanding? See how long it takes for people. 1970 to 1996, 26 years. Lot of intelligent people around the world, right? But it takes 26 years. Lot of application for the lesson. Lot. And the same guy, the Robert Piccioni, it took him again another 11 years to develop elastic net. How? He just added these 2 penalty together. So what is this is Lasso. This is called the Lasso. This is called the Lasso. This is called the multiple linear regressions. This is called the Rees regressions. And what is elastic net? Elastic net is just this sum of yi minus beta xi square lambda beta I plus lambda sum of beta square. So when 2 penalty from Rees and Lasso are added together, that regressions become elastic net. Are you understanding? When the penalty from Rees and Lasso are added together and subject to the conditions that their absolute value less than a certain value, their square value less than a certain value. Actually, suppose if their absolute value equal to 10, then their sum of square value should be in such a way that each value is coming from that are contributing to becoming 10. This is called the elastic net. Elastic net. Now I have to, so you can so let me write something in there. Let me write here multiple linear regression. I will derive soon. Let me write it so that I. So this is the multiple linear regression where you minimize residual sum of square. Okay. Then I goes 1 to n. I goes 1 to n. Then we did the Rees regression. Where we minimize this yi minus beta xi square plus I can write here lambda sum of beta I square. Okay. So actually this could be written as actually like y minus x beta prime y minus x beta. And then Rees regression after that, we can write here Lasso. How can you write the Lasso? Lasso you can write here again Lasso regression. You can write here y minus x beta. I wrote it in terms of okay. And then what is elastic net? This is the elastic net. I will give the explanation why elastic net is needed. Elastic net. Elastic net. Elastic net is written y minus x beta transpose y minus x beta. 2 penalty added there. You put here lambda 1, you put here lambda 2, and then sum of beta I, absolute beta I. This is what called the elastic net. Okay. Remember, I give you an example of gene, right? Human body contains exact number of genes. Still, how many types of genes human body contains? Exact figure is still unknown. And even there is genome project in America in 90s, it was established. So the genome sequence for each person can be known. And if that can be known, personalized medicine can be developed. So you will have a medicine that will be different from mine. Same disease we have. This is called the personalized medicine. How can it be developed if your genome sequence is completely known? But right now, it is unknown in this modern world how many different types of human gene human body can contain. Okay, I was reading a 3-page article. I found there is more than 100,000 genes and a lot of them will still not know. So in such a cases, collecting sample is very expensive. So this guy, suppose this guy will be given, this guy has given consent that, well, I will give you the sample 10 times. Each time he will give the sample, he charges 1,000. Understand? Each time his transportations, his lungs, and then in addition to that. So the drug that are development, $500, $600 million is spent already for the clinical trial, all of this. And during the middle stage, third stage, they found something error. All money lost. All money lost. All the clinical trials that are happening, 10% getting success. Even 10% getting success, they come out as a medicine, they are sold, and 5 years later, the medicine is withdrawn. You saw that thing, right? Medicine is withdrawn because it has a side effect. So the sample that are taking from this bone marrow, most important part of our body, bone marrow. You know bone marrow? So did you eat like the cow leg? And then there is some black things, you know, most important thing for our body also. So our antibodies, so that when the injection is given, because I was working Moderna for it from beginning to now for a vaccine development. Listen, very interesting. Suppose he has a flu. He is very angry. Doctor, I went to your office, I took the vaccine, and then why I still have a flu? The doctor said, doctor does not know. Doctor said, oh, I don't know. Because in America altogether, 5 different types of flu strain. You are given a vaccine for a specific strain, specific type, but you are affected by the other. You understand? My daughter has a fever for the last 4 or 5 days, and today we took her doctor. My wife took her to the doctor. Doctor said that she has a flu. My wife became angry. Then why did you give her a vaccine? Like we already gave her the flu shot. And doctor said that. Like nurse said, I do not know. Then because my wife cannot go to the work. Understand? And then the employer will be very unhappy if she cannot go. She works from the home, but she cannot go there. She's angry over me. So I told the nurse was unable. I explained to her. So that is the reason. You understand? And Moderna is getting very crazy. All the vaccines that are existing in the world, that are egg-based vaccine, modernized, rapidly transforming all the vaccine to the mRNA-based vaccine. That is much quicker, easier, and safe, less expensive. So if you search in the YouTube, how vaccine are produced, Pennsylvania, there is a vaccine production facilities. Chicken eggs, millions of chickens eggs are coming. They put some injection there. They put that in a certain temperature. And then after that, they do the another processing, another checking, all of these things. So the reason I said, this guy want to give sample only 10 times. And each time he is charging $1,000. How many people we are recruiting? 100 people. 100 people, and each people charging $10,000. 10,000 times 100. Understand? And then not only that, after taking the sample, so 110 times. So how many? 1,000 sample, right? So 100 people, 10 times 1. Each sample, if you go to the lab for analysis and taking all of this, they will charge for each sample 4,000, 4,200, 3,500. I was involved in all of these things I saw. You cannot believe how much their money they are charging. And those like labs and this, they are all highly talented people are working there. And then they write all of this. In such cases, I'm now giving you why elastic net is important. 100 genes, right? 100 genes. If you run only the risk regressions, they can reduce estimate, but they cannot kick out. Clear? If you run only Lasso, they can kick out until amount of observations. Suppose you have 160 observations, they can kick out only 60. After that, they cannot kick out. Understand? Suppose you have 100 genes and you have 60 observations. From 100 genes, they can kick out only 40 because they cannot go below the number of observations. Understand? So elastic net, what they do, they kick out unimportant one and then start reducing the coefficients value by the distribution. That is it. Do you understand the difference between four regression, multiple regression, risk regressions, Lasso, and elastic net? These four. So if someone comes to you walking in there, I do not know, I have a lot of variables, I don't know which one I should choose, and I do not know the expertise, so I don't have to this and that, this and that. Is the Lasso. Lasso is not enough. Then you can then use the elastic net. Clear, right? So I have given you the fundamental. So let me start deriving Lasso. Okay, then I will start discussing homework. This homework, I'm not going to give you any code. Okay? Okay. Okay. This is a long derivation, it will take some time. Okay. Okay, you can take like 5 minutes break. I just want to start new things. So I want to give you 5 or 7 minutes break. Okay. Then I will derive these things. Yes. No project. Homework is enough. I will update the syllabus. Okay. The more assignment I will give you, you will become very smart. Okay. Cut sleeping hour, cut entertainment hour, cut everything. To rest. Any class did you learn principal component analysis? Principal component analysis, did you learn that thing from any class? No? No class teaches you principal component analysis? No, so far. What kind of class will teach something like that? I don't know what kind, I just asking. If not, maybe I can also discuss that one. Oh, yeah. Definitely not, huh? Yeah. No. Principal component analysis. Let me see if I can squeeze some time, I can upload a lecture. November 17th, there will not be any class face-to-face or remotely because I have been invited to give a talk at a university. So on that day, there will not be any class. Neither, yeah, 17th is Thursday? Yeah, that's yeah. Next Thursday, there will be class, but the 17th, there will not be any class because I will be at Ball State in Indiana to give a presentation there. I already, so I graduated from there with a master's degree. Oh, really? Yeah. Yeah. So they asked me to give a presentation there. I said, well, I'll go. So it is a 4-hour drive from here, right? Yeah. Yeah. 4 hours drive. It's Box, no, they invited me. It's university. Box said, yeah. So if you are interested, you can join, you can see what type of research I'm doing. Whom? I don't know. No, there will be graduate students, faculty, they will be there. So if you want to come, it is a 4-hour drive, so you can come and join. And if you are interested to see what research I am doing, you will be happy to see what type of research I am doing. Okay, let me start deriving. Let me start deriving Lasso regression. So Lasso regressions will be this. I can write here arc min. That means I want to minimize these things with respect to 1 over n, which is called the average. And I goes 1 to n. Yi beta 0 minus sum xi j. J goes 1 to k beta j square plus my penalty this is the penalty that I want to minimize 1 to k. So I can write here in this format. If I want to reparameterize these things, I can write it in the following format. How? What is the format? Residual sum of square of the lasso I have written, and I reparameterize as a theta, and then residual sum of square of ordinary least square with respect to theta, which is equal to exactly this, plus lambda sum of theta I can put here something like this. Now, if I want to take this one, R, S, O, L, S, this one, and then I want to write like this way, half sum of M, I goes 1 to like this, yi minus theta j x I j. Now you can ask me the question, why, professor, you put here half? So it is just a constant. It doesn't matter whether you half or anything. If you put it, it doesn't matter. They are putting these things in order to maintain that it could be the sum, and they are taking the average over just the two quantities. So that's the reason. This half does not make any sense, because ultimately when you will differentiate, that will be gone forever. Or from these two come will make it in a year 1. Or another approach is when you like equate it to 0, then these two will be gone. Actually, they put in here so that when they will differentiate, this differentiation 2 will be cancelled out with that. Okay, so that's the rationale, nothing else. Okay, now if you take a differentiation of that with respect to theta j, r s o l s theta, then you are getting here minus m I goes 1 to n, and then yi minus summation theta j x I j. J goes 0 to n or p, something like this. That means k or p. So after doing this, now you can write here, there should be a xij because I differentiated this. So there should be xij. Now we have in here in this format, negative xij and then yi, and then I want to put here theta ik and then theta I, theta k. So this is just the theta k, sorry, theta k, and x yi minus sum theta k and then x ik, and then when I plug the value in there, j is not equal to k. Why j is not equal to k? Take a look at that. This summation is taking over the I. If I put it in here, then j and k would not be the same because I'm taking out the k1 from there. I'm taking out the j1 from there. There is a rationale. I will explain. So this is equal to p. This is equal to p. It has been written like this way. And then theta j sum of xij square. Okay, let me rewrite these things. It is not clear. So let me rewrite these things again. Let me rewrite these things. Let me rewrite these things. Theta j sum of x ij square, and here I equal to 1 to n. Okay, let me come to the board now. So this is what is still ordinary least square. I want to put it in a beautiful format so that when I focus on the non-differentiable part, there could be consistency. So yi minus theta j xij. This is just the residual sum of square and square in there. When you take the derivatives, then this half and then that one is gone and it is written like xij, right? Clear? This is just the previous one. Now, if you bring it in here, yi like this format, I take out here, I take out theta j part. J part I take out. So in this case, j is not equal to k. In this case, j is not equal to k. Take a look at it. This times that equal to this, right? This times that equal to this. In this case, theta j is not equal to k. I am taking out theta j and I takes value 1 to n all the way. Clear this one? Okay. So now I want to write like this one. I want to write like this one as a, this part I want to write. This part I want to write as a rho j. This part I want to write as a rho j, and plus this one I want to write theta j and gj. Ultimately, this is just the sum of the square of the explanatory variable, which values are known. I know this value which I write as a gj. Clear? So this entire part reduced to that. So go there. I had two parts. One is this one another one is that one. I already focused this part. This part I brought down to in here. Now I want to focus on this part. Clear? Now I will focus on this part, okay? This part I will focus now. Now, that part, if I want to focus, like the penalty part, now I am going to focus penalty part. So penalty part, in order to focus the penalty part, let me go there again. Take this one. Lambda sum of P or K, and then I goes 0, J goes theta J, and then theta J plus lambda K equal to 1 to P. I can put here theta K in here. So now I can write here theta J plus C. Now when there is a regression coefficient, we differentiate with respect to each beta, right? We differentiate with respect to beta 1. We differentiate with respect to beta 2. We differentiate with respect to beta 3, right? So now I separated it as a theta J. I want to differentiate with respect to theta J. So that means theta J is coming from there. Theta J comes from there. When I differentiate this, there is no theta J in here. It would be 0, right? Take a look at that, what I did in here. Theta J is my beta J, right? Is there theta J in here? So here, from there, J is not equal to K. So whatever value I will put here, K equal to 1, 2, 3, 4, 5, 6, all the things, I cannot put here K equal to J because I take out the J part in here, I put it in here, and then I multiply this with that, I will get this one. So if I differentiate this, now I target one after another. I will target one after another, right? You understand? So suppose you gang up and you insulted this guy, okay? He says that, well, now the gang is very big. I'm not going to do anything. Let us keep my mouth shut, okay? But he secretly planned that I will target one by one. You understand? So I am targeting one by one. Clear, right? Because that part has a absolute sign. That is why I am targeting one by one. That is why I am targeting one by one. That part has an absolute sign. So now I can write it minus theta J plus theta J and 0. Clear? This one I do not want to focus. And then I can merge this one with that one, and then I can make the differentiation. Are you getting it? This one? It's called the rho. So why I write like this way? This one does not have any theta J. So that is why I put here rho J. Clear, right? Okay. So now I have these things could be written as theta J, and you can put here 0, or you can put here minus theta J, comma, plus theta J, when theta J greater than 0, when theta J equal to 0, and then you can put here minus theta J when theta J is less than 0. And then this constant sign, if I put here constant C, Constancy doesn't matter because if I differentiate this, it is 0, right? That is why I did not, you do not need to put your constancy. See, this has become this. Now I add this quantity with that quantity. This quantity I will add in here. Because this part is definitely coming from the residual sum of square. And that part is coming from the diamond penalty in 2 dimension. So this will be added in there now, and then I will differentiate. So let me write case 1. Case 1. So this is called the residual sum of square. Case 1, we got here rho j theta j, rho j plus theta j gj plus theta j gj plus lambda theta j. Case 1. Case 2, RSS, residual sum of square, rho j theta j gj minus lambda this. And case 3, so in the case 3, case 3, theta j, when this is, as I mentioned in here, theta j equal to 0, right? In this case, estimate of theta j equal to 0, right? So case 3, theta j equal to 0. Our purpose is to estimate theta j. Now, if you differentiate this, RSS case 1, RSS case 2. Let us differentiate these things with respect to theta j. D R S S 1 D theta j equal to 0. If you plug, then you will get here D G J plus did I miss something somehow? Theta j is in there, right? Okay, so if I miss in there, it should not be equal to 0. Okay. Are you saying? It is already operated, right? It is already, so differentiation is already taken over there, right? You understand? Differentiation is already taken over there, right? Then I come in here. I cannot take derivative again over there, right? Are you understanding what I said? I already take a derivation, so theta j would be in there. So in this case, the way I have written, so here, what I did in, where is my this? Yeah. So this means I already take the, I already take in there. Now I have to take the theta j is in there. So let me correct these things little bit. Let me correct these things. This is not the correct thing. This is not the correct thing. I already took the derivatives in there. I have to take derivatives over in here. I have to take derivatives over in here. Now come in there, take derivatives over in there. Good. I have to take derivative actually in there. This is sum of theta j. J goes 1 to P, 1 to P. Then it will give me these cases. I have to take in there with respect to theta j. I will have a lambda in here, positive lambda. I will have a negative lambda in there. So let me see the final solution. Yes. I will have a positive lambda, negative lambda in there. I will have a positive lambda in there, positive lambda, 0, and negative lambda is in there. If I take the derivative, if theta j greater than 0, if theta j itself equal to 0, if theta j is less than 0. Now I have to add them up because this is equal to 0 now. If I add them up, how can I add them up? Let me go there. This part, and this part equal to coming in here. And that part I want to add. So I have rho j plus theta j gj plus lambda equal to 0. This is what we have. Now I have to estimate from there theta j equal to, so theta j equal to what we are going to get it there. Let me check. Here is the negative sign. Where did this negative sign come? This negative signs come from there. Are you seeing this negative sign? This negative sign should be in there. Here. So now theta j equal to what you are getting? You are getting this minus lambda over j under the condition that theta j greater than 0. Okay, theta j greater than 0. And then you will get another one, another equation. This is the case one, and then case 2, you will get theta j equal to 0, and case 3, you will get minus this plus theta j, gj minus lambda. Then from there, you will get theta j equal to this plus that divided by gj. So this is the way you can solve. So what I did here, this is a residual sum of the square. I am minimizing these under a conditions. Condition is what? Absolute sum of the coefficient is equal to a particular constant, right? Absolute sum. And then I first targeted the first part where I separated theta j from the others. I separated them, and then I differentiated the different cases of theta j, and then finally get up these results. Okay. So now elastic net is what? There are three quantity. One is elastic net is this one just. I did not derive this one because the derivation is in there already. So elastic net is just in there. If you want to do like residuals, minimize residual sum of square yi minus x beta, subject to the condition that sum of beta j is less equal to C1 and sum of beta j is less equal to, suppose if this is equal to C1, then suppose this is equal to K or like C2, something like this. So what is the application of this part? As I said, if you have a very high dimensional data, like gene 1, gene 2, gene 3, gene 4, up to gene, suppose 1000 gene. Okay. And then this is the person 1, person 2, person 3, person 4, person 5, person 6, person 7, up to maybe just 50% is enough. 1000 gene per person, he will give 1000 sample, he will become rich, right? And then you want to fit predictive modeling. All the genes are not relevant for causing cancer, right? So amount of cancer you have, like your cancer is spread on this amount of cell, that is what the measurement, dependent variable. Amount of cells that you have in your stomach or somewhere. And then these are the all gene types. And all genes are not responsible for causing cancer. So, but sample are taken, you want to kick out some variables that are not important. Elastic. Why? Because until if you use the lasso can reduce until 50. So they can come here until 50 genes. They can reduce, kick out 950 genes. Not important. After that, they cannot. Lasso cannot go beyond that. So what you will have to do, you have to use the elastic net. The remaining 50 genes, they will do the contractions, they will do the shrinkage, and then they will reduce the estimate. In that case, your predictions will be reliable. Clear, right? Okay, so now let me upload the materials. Please read all of this material, very important material, and this is the derivations I have shown you. Let me go to the here, homework. Yes. This what document? Okay, I will. So take a look at that. Last number of your student ID is odd or even? Last number of your student ID is odd or even? All of you or some of you? Huh? Even, right? So even people will use one data, or people will use another data. I said in here, for this homework, you must use one of the two data. Take a look at this. For this homework, you must use one of the two data known as class practice data or homework one data. So the students whose student ID number is odd can use class practice data. So your entire student ID could be either odd or even, right? Any number can be either odd or even, right? But there is student ID with 0, right? There is no student ID with 0. So if you have the students whose student ID number is odd can use this data. Other students whose student ID number is even can use homework one data. So one is class practice data, one is homework data. Clear? So when you submit your homework and you will have to write a report, please write the student number in there. Okay? Okay? Please write the student number. Okay, now see, take a look at this. Very simple. Fit a multiple linear regression model by choosing a dependent variable and at least 20 predictor variables. At least 20 predictor variables. Write down all regression parameter. You must include height and weight as predictor. Why? I said height and weight. Because they are also correlated. They are also correlated, right? So you can use height, weight, BMI, all of these. Height, weight, BMI you can use, and then you report your estimate, okay? The second problem, what you are going to do, you run the same model, but use the Ries regression. So in the Ries regression, when you will run, you will see the estimate will be shrunken. You have a question? Yeah. Okay, so if they detect the collinearity, so in that case, if you, okay, could you please stop talking? He raised a question. If he is going to run this model with 20 variables, what will happen? The program software can say that there is a singularity problem, there is a collinearity problem, so we cannot get the result, something like that.
I think it'll just choose a variable to kick out what it will do.
No, if you do the multiple regressions, they will not kick out anything. Okay, but when you run the Ries regression, you will see the difference. Ries regression estimates will be shrunken. It will be reduced. It will not be inflated. So run the Ries regression instead of the multiple linear regression with the same response and predicted variable as in problem 1. Write down all regression parameter estimates. Write a report by comparing the regression estimate between problem 1 and problem 2. This is the problem 2.
Yeah, but I'm pretty sure if you run like a regular linear model and you have like vertical linearity, it'll detect that and then it'll just pick one of the two variables with collinearity to actually keep in the model. It'll get like multiple together, I'm pretty sure.
In R, this year?
It's either or for R and Python. Those two.
Okay, do it in the R. Okay. So far, I remember maybe, but email me. Okay, if there is something like this, email me, and then you will have to figure it out how to solve this problem, and you have to write those problems in your report. When I read the report, then I understand that well, the student tried to use all the 20 variables, and then he found that the model is not running because of multicollinearity. So he avoided these variables, and then model run. If I see this type of reports, so then I will understand that what the student really run. Then I will run, I will find it. You understand? So the change that I'm giving to you, that if you run the multiple linear regression model, there is a collinearity when that multiple linear regression model is run smoothly or not. And if it is running smoothly, then you will get different result when you run the Ries regression. Clear? Ries regression. And then after running these regressions, you have to run again the Lasso regressions. Then you will compare between 2 and 3 and also 1 and 3. I did not write here 1 and 3. You have to write for each of these questions. You will give the R script and as well as answer each of these questions. What did you find? What?
Yep.
And then last one is run the elastic instead of the multiple linear regressions under the setting in problem 1, compare the results between regression estimates of the problem 3 and problem 4. When you write the report for this one, compare this and that. Okay. And when you write this one, compare between this with this. When you write this one, compare between these three. In multiple regressions, I got these variables significant. But when the estimate is like this, when I run these regressions, I found these estimates are reduced significantly. Okay. And first one, multiple regressions, I got out of 20, only 14 variables significant. And in these regressions, I found only 7 variable significant. And in Lasso, I found like 5 variables significant. And in elastic net, I found altogether 3 variables significant. And then write each sentences. Now, if you use class practice data is a longitudinal data, right? Understand? If your student ID is an odd, you are going to use class practice data, right? But class practice data is longitudinal data. None of this model is suited for the longitudinal data. You understand? Why? The longitudinal data is repeated measurement. Same person is measured 2 times, 3 times, 4 times. So that means within that data, there is a correlation. One of the assumptions of this model is response variable are independent. In the 4 regressions that I have discussed, multiple regressions, actually all the regressions that I discussed, all of this, Poisson regression, negative binomial regressions, and then multiple regression, Lasso, elastic net, these, one assumption is that response variable, dependent variable is independent. But repeated measurement, the variable are dependent, right? If I take his blood today and 6 months later, I will again take his blood and I find that he does not have any diabetes or maybe not high cholesterol, not triglyceride, right? Same person. On the other hand, if one person has a diabetes, 6 months later, I will say I will still see that high blood sugar, right? So if person is coming in the data, repeated measurement, that data is correlated. The response variable is correlated. So how can you handle that problem?
I guess you can just either pull it as a cross section or you can cut out.
Okay.
Just select one observation.
Okay. That set of code, now I'm going to give it to you. Okay. That set of code. So let me go there. Open script. Go to week 2 maybe. Yes. If I see that you run class practice data directly, I will directly give you 0. Because you are running wrong data on a model which is not perfect for that data. Understand? If you use the homework one data you will use only if your student ID is even, right? That there will not be any problem in there. But for the class practice data, if you want to run, what you will have to do? You have to do these things. Let me see if it is running. No, it is not running. Let me see if it is running. No. File.choose. Where is file.choose? Here. File.choose. So I have to do the class practice data. Class practice data here. So I run class practice data, okay? Clear? Class practice data, this line of code is run. Now, what should I go? Where should I go? I should go I should go there. This one. Deleting any missing values, okay? These two line of code, right? D2. Now come there. Here. D3. This 3 line of code you need. You will do all operations on D3. Now D3 data does not have anyone, okay? I am going to tell you, if you run directly on the class practice data D1, that is a wrong data you are running on this model. You have to run D3 data, okay? Take a look at the D3 data. Windows, file horizontally. Take a look at the dimension of D1, dimension of D2, and dimension of D3. What? Hold on. Let me check. Oh, I did not define new ID. You understand? I did not define new ID. But what I can do in here, understand? Clear? Just ID. Unique ID I'm selecting. In the data analysis and data mining part, I taught you how to create a new ID and delete the existing ID in order to de-identify the person, right? Right? If you have if you know a guy whose identity you know, and your boss give you the data and some personal information is released, and you secretly want to make a agreement with your friend, I'll disclose this data to you, and then you will file lawsuit against the company and you will get $1 million, give me half. Give me a cut. That is why your boss is very clever, okay? Very clever, your boss knows. And then company computer that you are using, you are connected with their VPN. Okay? If you use your personal email, because I'm working on the Moderna as a consultant there, and some paper ID, very beautiful, very fantastic, just paper. And I saved my one personal email address to another personal email address. I sent it, but they noticed it. They said that, Mohammed, you send me this file. They send me the last list of files. List of files they send me. And then my manager is normal. I want to talk to him in a few minutes. Yes. This is I got this thing from ID. Oh, this is the publicly available paper. This is the publicly available paper. I got it because of our research things. And then I just saved it. Then my manager see all of this thing. He said, okay, don't worry about this. I will tell you the ID. Okay. When you are using computer, they super smart people give you. Whatever you are sending, they are not receiving. Even you use one personal email to another personal email. Because I did not use the company's personal email. I can show you the email that they have shown. So be very careful about people's identity, okay? Be very careful because the person identity you disclose, he has a medical condition. He said that, well, so now my identity is known. It will be difficult for me to get a job because I have this medical condition. Well, I have these things. Okay? Clear, right? Be very careful what you speak, what you do. And always honesty is the best thing. So those people who have a student ID email, they are very good to use all of it. Now, where can I get the code, right? I did not give you the code, right? You can just like this. So R code for Rees regression. Rees regression in R, step by step, staterology. Step by step, they will give you everything. Okay? Clear? Why I did these things? If I give you the code, then what? You will just copy and paste. Now you will search the literature, you will spend time, you will learn. Okay? R code for Lasso. You will find it. Okay? R code for investigation. Some smart people, they are doing their job for us. Understand? Rest of the things I'm not going to give you the code. I will teach you little foundation so that you understand why. Why we need these things, right? So there is some limitations of one method, they develop new method. They develop new method. They will develop new method. When you will come to the research stage in become a faculty, you will see people are doing research by extending the tail. It's called they are extending the tail. So something is done. They said, well, I could do little better like this. Well, I could do little better like this. That's the way people are publishing, doing research sub paper articles. Okay.
So, Professor, in the class practice data, you say we should use height and weight.
Yeah.
So we have
on the D3 data. That I ran the D1, and then D2 is the what? D2 deleting any missing value, any row that has a missing. D3 is selecting unique ID. On that data, you can give 20 variables, but do not use nonsense variable. ID number can you use as a variable? No, right? I'll be very mad if I see some students give ID number. Okay, ID number is given, I deduct 25%. No, sure. If anyone use ID as your predictor variable, 25% will be deducted immediately. No, that is why I said I give you warning. That means you are careless. You are not caring about anything. Okay, if you do not have any questions, I'm going to stop in here. Okay. So next class, I'm going to discuss what? I'm going to discuss maybe Cox regression or linear mixed effect model, or maybe I'm going to discuss about maybe principal component analysis, something like that. Did you do the principal component analysis? You did the factor analysis.
So, Professor, regarding the deadline, is there any way we have
this one? When is the deadline?
It said the 13th.
13, right? Well, so then I can extend 1 week because 17, I'm not taking in class, you know, right? 17, I will be in the Ball State University, Muncie, Indiana. I will give a presentation there. I'll give a talk there. You are invited to come on that day. There will not be any class. So I can extend it 1 week. But you have to do everything. Rest of the works, I will give all the theoretical things. Actually, the way I discussed today, if you go to the graduate level class, professor actually do these things. They give the theory, they discuss all of these things, and then they give you the homework. And when if you will be enrolled in the PhD, professors will say that, no, you are not allowed to use any package. You have to write your own code. Okay? The professor said that, no, you use the built-in package. You are in a PhD program, you have to write your code. You write your code, then you have to write your own code. So now the Lasso, so for all the estimates that I gave in here, you have to write all of this manually, and then you have to do this thing. Those are the things that we do in PhD level. But that's the way, like the generation to generation, they are knowledgeable and knowledgeable and knowledgeable, right? Pushing you so that you have no other option. Either do the PhD or drop out. Okay. And then top school, if you get, you go. Like if you seek an appointment, the professor give you maybe 10 minutes, 15 minutes, 20 minutes. Go to the teaching assistant and see him. They do not have a time for doing research. They are doing a lot of things, research and then writing for the grant and then meetings and teaching class, all of these things. Okay, so 28 is the Sunday, right? Okay, yeah. Yeah.